My name is Christopher Litsinger. I'm Director of Cloud Application Platforms at Comcast Cable. You can find me on Twitter. Those are my personal pronouns. So when I started at Cable, I was really excited about the scale of the company. Certainly, for those of you who aren't familiar with Comcast, maybe live outside of the service area, we're the largest cable TV company and home internet service provider in the United States. And so I was brought in to work on a project that had the potential to really scale at that level as well. So to kind of set up with the background, when I came in late 2014, Comcast had a commercial API management gateway in place. We were paying a software as a service provider. We were handling about 2 billion transactions per month on that platform. There was a small pure operations team in place to handle that. They handled things like onboarding new services or adding new credentials and interfaced with the vendor through their ticketing system. We were paying a lot of money for the privilege of using that platform. We were getting relatively terrible service from that provider. One of the most critical shortfalls was in terms of operational visibility. There was a lag of at least an hour before we could see real-time logs from the system. So people would call us up and say, hey, we think there's something wrong with the system. Could you take a look? And we'd say, well, call us in an hour and we'll tell you what happened, which is, no one wants to hear that, right? On top of that, although we had originally designed the system in a way that made sense, it turned out that in the way a lot of our users were using the system, we had two services sitting on the same virtual hypervisor talking to each other over a virtual network, and yet to call out to a software as a service provider, they were going out to the public cloud and back. So we were adding a huge amount of light speed penalty as well as the latency for the system itself, which wasn't super performant. And on top of that, we had really customized ourselves into a corner with a vendor. One of the great things about being a really big company is you can convince vendors to build features for you, but don't do it. It's terrible. Because we found ourselves, as they improved their platform, we got out of mainstream. And every time we tried to upgrade to a newer version, we would cause outages for our customers, which wasn't very popular. So a little bit of bar thoughts. John Moore, who is currently the chief software architect at Comcast Cable, was thinking a lot about microservices at the time. And he realized that the traditional API management gateway was approaching specifically rate limiting in a way that's a little bit limited. So how many of you are familiar with Little's Law? Little's Law actually comes from the field of probability. The paper was written by a guy named John Little. No, that's not the guy from Robin Hood. In 1954, really applies mostly to manufacturing and retail sectors. And it's queuing theory. And basically what John Little realized was that there's a relationship between the transaction rate, what we think of as requests per second, we deal with all the time in API systems. There's a relationship between that transaction rate and the wait time. And the product of those two numbers actually gives you the number of units you can handle in a system at the same time. So his original example actually had to do with like how big your wine cellar needed to be based on how much you drank wine. But it applies really well to the field of computer science. And the reasoning is simple. So you think of a traditional kind of simple microservice. Chances are there's a database at the back end. And when you're designing that and standing that up behind an API management gateway, you have some unit of how many transactions per second you can have. Let's say it's 10. Just pick an arbitrary number. So 10 times a second, you get a call in, you make a call to your database, you get a response, and you send it back up the pipe. No problem. Well, what happens when the database starts getting impacted? We've all been in this situation, I'm sure, where the transactions are still coming in 10 per second, and the system is now relying on a database that's maybe taking 5 times as long to respond. And so realistically, our throughput rate has gone way down, but the API management gateway thinks, okay, they can handle 10 requests per second. And sooner or later, you end up with enough data coming into the system that you just overwhelm the available resources because your system can't manage that. And so your service ends up falling over because of its own back-end dependencies. And so instead, if you measure how many requests you can handle in the system concurrently, how many you can handle in your system at the same time, that will never happen. No matter how much your dependent systems are impacted, performance will remain static for your system because the API management gateway is managing, instead of managing how many requests you can handle per second, with an API management gateway handling how many requests you can handle at the same time, you'll never get overwhelmed. And so this is identifying really a critical relationship between the latency in the system. So the formula, L is the number of transactions you can handle in the system, lambda is your request rate, and W is your wait time. And so by sticking with the left side of that equation, we've recognized the relationship between those two things. And the API management gateway simply returns a 429 or a 503, which tells the client calling, okay, I've exceeded my available rate, and so I'm going to slow down a little bit. Now, at the same time, we were also thinking as an organization a lot about DevOps at the time. The relationship between developers and operations teams is sort of, at this point, a pretty well-known problem, right? We had all the problems that are associated with that in our own teams, handing off applications to an operations team that was responsible for operating it, and neither the developers nor the operations teams had full responsibility for the software, so there ended up being a lot of finger pointing. Because I work in the office of the chief software architect, we've always been a little bit of a laboratory for some of these ideas within the company. And so we decided, as we were looking at building a new API management gateway, to do this as a DevOps team. So we were going to develop our own gateway. We were also going to operate that gateway. And the idea in our heads was that this would eventually become feature complete and we'd be able to sort of backburner it. We were going to build a fully self-service system so the team didn't need to be involved in standing up new APIs or handling credential requests, and we'd be able to work on move on to other development projects. So to summarize, we felt we had a really good design for the system. We were going to build a system that handled requests based on concurrency rather than on a request per second rate limiting model. We were going to build it in-house. We were going to develop a full self-service system so that we could get out of the business of handling onboarding services or adding credentials. We were going to send our logs to a common logging system that was used throughout the company that we could get near-ish real-time information out of, which was a huge improvement over the wait an hour and we'll tell you what happened model we had before. And we really felt that with that we could build a performance system that would improve on what we had from our vendor. And we also thought we had a good design for the team. We were going to do DevOps. This was emerging as best practice. And we had a real small, talented group of software engineers that were pretty motivated to go and chase after the problem. But in the meantime, we had a lot of pressure because we were paying the vendor month after month. And in fact, as the system was starting to grow, we were starting to pay overage charges. So we really wanted a quick win to kind of show the team turning a profit within the enterprise. So we made a decision that we were going to build the core engine for the API management gateway first, migrate traffic, and then work on building the self-service system to allow onboarding and credential management later. So we built the engine. In fact, we built it. Comcast does a lab week 3 times a year, and engineers are free to work on whatever they want to. And so John, who I mentioned earlier, worked with a gentleman who's currently my lead engineer. They sat down for a week, and they really built the core engine that we still use today in that week. And the pressure of lab week, the pressure of trying to build something as quick as possible to get it done in the context of a week really drove a lot of the decisions that turned out to work really well for us. we had to find existing tools. We had to find open source tools to help us build the gateway. The last thing we wanted to do was open a socket in Python or C and start listening and try to figure out what to do with it. So NGINX was, of course, an obvious choice for us as a really performant API management gateway. And we're really excited about the OpenResty toolkit as well. We had a week to write it. We had to maintain it. No one was really enthusiastic about doing a C-based plugin, so being able to write it in Lua instead seemed like a fun approach for a lab week project, and it served us really well. So no complaints about that. So yes, they built the core engine in about 1 week. It took a lot longer to fully build that out and operationalize it than it did to author the original software. And of course, to migrate tenants took still longer. But we did get it out, and we threw a release party, which is what you do. I'm pretty sure this is a picture, actually, of the party. And people were generally happy. In fact, this is what our first customer migration looked like, or client migration. And you can probably see this kind of divider where the new service comes online. Nerds with lasers. Ooh, it's green too, which means it's 52.7% more nerdy. So anyway, this is the old median for the previous vendor API management system that we had, and you can see that when we make the cutover after a little bit of a weird spike there, that old median became the new 99th percentile in terms of performance. So we were pretty happy that we had built a system that performed as we hoped, better than the system. And this actually was a unique case that wasn't paying the light speed penalty. So this is just pure system performance for the API management gateway itself. And luckily for us, the team that we migrated was one of the highest volume APIs in use in the company, and written by a team that had a really good reputation. The director sent this lovely quote you can read down at the bottom, and that did a lot to assist us in our efforts to move more people over and bring new people in to the system. In fact, this is kind of what happened. We went from handling, so I mentioned the commercial system at the time we decided to replace it was handling about 2 billion transactions a month. By the time we shut it down, it was handling about 3 billion transactions a month. And over a period of about 2 years, it grew almost 15x to handle about 43 billion transactions a month. We currently handle over 47 billion a month. We peak, the cable industry has this really interesting problem where our peak traffic is driven at the top of the hour when everyone starts tuning their cable boxes. We get this crazy spike in usage. And so our peak transaction rate when, say, Game of Thrones is on or something like that looks at like about 33,000 requests per second. We're currently about to drive that to, I think, about 55,000 requests per second. And all this is running on virtualized hardware in 5 data centers. So, and in addition to sort of that organic growth of the services we've also been supporting an increased. Comcast keeps building new microservices, right? And because of the reputation that we were able to establish earlier, generally speaking, when you build a microservice, you end up hosting it on our platform, which we call Code Big. And we also end up hosting some weird monolithic services and other sort of things as well. And as Comcast has begun syndicating our services to partners, we've just had incredible growth within some of those services, especially. So this is generally the kind of growth that you look for, right? This is what you hope for. If you were a startup, you'd be like, yeah, this is good stuff. And it was certainly being good for my team as well, and in terms of our reputation within the company. And if you look at a per transaction rate or on a data transfer basis, we were just saving the company tons of money. We were paying overages at 3 billion transactions a month, so you can only imagine what what level of overages we'd be paying at 43 billion. Clearly, we'd need to renegotiate our deal. But this is the kind of growth we didn't really want to see, but unfortunately we were seeing. as I mentioned, we decided in order to accelerate the release of the service itself and to stop paying money, we released the engine before self-service was ready. And so every time we needed to onboard a new service, or every time a credential needed to be created, we needed to do that. So we added about 900 services, we added about 3,000 credentials, and all that's reflected there in the graph of how many tickets were open with my team. And it's worth noting that was kind of a pure OpEx increase if you think about your expenses in terms of capitalization versus operational expenses. And we didn't add much in terms of people. So we started with 4, we ended with 6. I think we have currently 6 full-time employees working on this. But so where we were getting that OpEx was out of stealing time away from the development of the system. So we desperately needed a self-service system, but we were growing so fast that it was the last thing we were able to focus on. Tickets are great if you're on the boardwalk. Tickets aren't really good within an enterprise. I'm sure all of you have a ticket management system that everyone hates. You know, Jira, like no one wants it, right? And so we were adding about 4 credentials a day. We were adding about 1.5 services per working day, and handling just tons of other questions. One of the interesting lessons we learned is that although I still believe fundamentally, architecturally, the idea of a concurrent request model is far better than a request per second model for protecting your services, it turns out people are really used to working in request per second, right? So we'd have these free-form ticket entry systems where people could put in whatever they wanted, and we'd end up with things like, I need 100 concurrent requests per second, which is, I don't know what that means. And we also realized that typically the people who were assigned to do API gateway migration were not who we thought we were building the application for. We thought we were building an API management gateway for software engineers. But it turned out in a lot of our company, what was happening was the time at which they would do the API gateway implementation was after the service had been turned over to the operational team and gone through a security review. Security would say, yeah, you need to get behind code big. And they'd say, hey, contractor, you just started today. We've got a project for you. And so someone who had no idea about any context of our system or the system they were working with would be trying to move it behind our API management gateway. And that didn't work so well. And the whole time we were going through this, we were dog-fooding our own automation, which was really good in terms of making sure our automation was working for us. We got to see it at every sort of baby step along the way, but it also increased the amount of time, and we kept changing our tooling. So once we got away from flat file configurations and we moved to a database, then we had to manage this database. So we ended up building a suite of throwaway command line tools for managing that database while we were working on building a graphical API for actually managing that data in a more sane way. And then we began making calls through the graphical API, which meant we all had these gist files with huge amounts of JSON data blobs and query blobs and mutation blobs for the graphical API. And then as we got the self-service portal wrapped up, we were using something that wasn't quite ready for prime time yet and encountering the edges of that system. And remembering what you had to do at what stage of evolution in the tool was constantly a struggle for our own engineers. And then it turns out on top of that, Comcast has like a whole lot of data centers. And it was really important to us as a service management platform that we be in all of those data centers. We like to be everywhere our customers are. But it turns out data center migrations, upgrades, and shutdowns became a thing that happened. And this was a fully virtualized system. So anytime there was a VMware patch, our VMware servers would go down. Anytime there was an OpenStack patch or a security fix or a new release, we'd have to shuffle around those things. And we generally found these out relatively short notice. Comcast just kind of seems to say, we're going to do this thing, and we go and do it, which is great from the, that we're able to do things quickly, but it can be rough when you're living inside of that system. And we continually had to drop everything and make that happen. There was just no choice around this, right? So I'm going to give you a second with this. This is a great quote. So our matrix wasn't filled with pissed off system administrators. It was filled with pissed off developers who were being forced to be system administrators, which is even worse, right? This can be really painful. It turns out developers don't love being operators or data entry folks, which is a lot of what we were doing when we were getting new APIs stood up in the system, even when they're using the tooling that they've built. By the way, this quote, Joseph was one of the originators of SRE at Google, and this goes into a lot of his philosophy the SRE philosophy is kind of built on that. So as I mentioned, we only grew from 4 to 6 employees during that time. In fact, we didn't deliver self-service capabilities until earlier this year, and you can kind of see a dip here where we finally had it. And then we realized there were some security issues, and we had to turn portions of it back off, and we had a spike again. And it has delivering that has made a huge difference in what we're able to do as a team. Like, I can go out and do things like give talks, which is kind of nice. But in the eyes of our leadership teams, although we had all that crazy growth we looked at before, in a lot of ways, the leaders that I report up to look in terms of development successes for the successes of a team. They're leaders who are used to running teams of developers, and so they're thinking in terms of features released and milestones hit there. The migration to DevOps kind of left us without tooling for measuring that as a performance. And operational reality was that this was a really reliable service. It was performing really well. It was very high growth, but again, we were just continually stealing time from development efforts to sustain the growth that we were having. So it's interesting because if we were a startup, VCs are really well positioned to recognize this period in a company's growth, right? When you have that kind of sustained growth, VCs are primed to just throw people at the problem. That's what they do. That's why they go for continuing rounds of funding. That's why they're well networked to bring in engineers to help you out. But our enterprises aren't actually very good at dealing with that same kind of high growth. We tend to say, you have a team. Like, that's okay. Maybe we'll hire one more person to help you out. I mean, you could look back at that previous quote and say that VCs do a good job of feeding the growth engine with humans. But the truth is, pre-revenue startups are really happy to operate at a loss. They scale. They don't scale back on people until actually they achieve revenue. And in a lot of ways during this time, we were sort of operating as a pre-revenue startup within the enterprise. And enterprises just don't have this concept, right? We want teams to be and stay very, very lean. And we never really stepped back and questioned whether our growth should impact our assumptions that we had about what we were doing. And to be fair, this is totally my failing, right? I'm a director. I run this team. It's totally my fault. So I'll explain this slide. This slide will make sense in a moment, I promise. So we never stepped back and questioned that DevOps model either, right? We had accepted that as something that we needed to do. And even as it became clear that this operational distraction that we were facing day to day was preventing us from hitting our development goals, we just weren't stepping back and looking. And we finally done that, and Comcast as a whole is really embracing the SRE model. And in fact, one of the ways we've described it, I told you I'm going to get to making this make sense, is that SRE in a lot of ways is an operational expenses trash compactor, right? You just automate and squeeze those expenses out of your system. So those data center migrations that we're doing, we have an SRE team working on automating those. And as you automate that effort, it becomes a lot more sustainable, it becomes much more efficient, it becomes less error prone, et cetera, et cetera. And it turns out that we're buying time back for our developers by squeezing that operational effort out of what we're doing. As a leader, I've completely failed to communicate our successes properly kind of up my chain. That's on me, right? This was really a question of framing properly what was visible to me close to the problem and making it easier for executives to see. Finding new stories to tell is something I've been spending a lot of time doing. Finding new metrics to measure our successes by. One of the things I added this past month in my executive summary was how many Slack messages my team handles on an average working day. By the way, it's 70, which is crazy. Right? And this is in the support channel. These aren't development questions. These are just practical, how do I do this? I'm personally really interested lately in the idea of using infographics to create a more engaging monthly reporting structure for my management. If anyone knows of a really great programmable infographics tool, please find me in the hallway track because I'm dying to be able to do this. And ultimately, the project has been a huge success, and I've been a little better about driving visibility into this. But we've also realized that we need to focus training on who our users are rather than who we thought they would be when we first started developing the project. We need to make sure that we have good education for why we have a concurrent request model rather than a rate limiting model so that people can understand that and understand what that means. We've been developing workshops and we've run a few of them and we've gotten really good feedback on that. We're playing with the idea of actually making training mandatory before you're able to use the self-service system to onboard a service so that you can kind of prove to us you have, or at least we've done our part to expose you to the things that make our system useful so that we don't get the question we all make fun of is, and I think this has actually been asked once upon a time, although that may be apocryphal, we've lost in the sands of time at this point. The question we always make fun of is, what is a code big and how do I get one? It's like, just the language of the question shows the lack. And we've also been working on user education videos. We haven't completed them yet, but the idea that someone could go to our wiki and see a bunch of videos that walk them through how to do the common tasks that we have to do will hopefully reduce the operational workload on my team. So that's kind of the stuff we've been doing. All right, so I'll go ahead and start all those. I'm a reader. My mom was a librarian. I always like to cite my sources. So these are 3 books that I would recommend if these are areas, if what I've been talking about resonated with you, is something you're struggling with. The Phoenix Project is actually a novel about DevOps, and it's highly entertaining and suspenseful, which is weird, but great. So if you're interested in DevOps, highly recommend the Phoenix Project. It's a highly entertaining read. It's a little bit dated at this point. The philosophy behind DevOps has evolved a little bit beyond what it talks about, but it's a great entry point. We've been thinking a lot about SRE, as I mentioned, and certainly you could do worse than to go to the source and read the actual book. So the last book there is by a friend of mine, Janelle Klein, who goes out and talks at a lot of conferences about the idea of actually finding the pain in your development process and working on fixing that. We spend a lot of time refactoring random things, thinking it's going to make our systems better. She's a big fan of actually using data to figure out where your problems are and addressing those problems. And my conversations with her and reading this book have been really influential in terms of my own thought process in where the pain is for my team and what we need to do to address it. So that's it. What questions do you have? Yes.
What are you doing now? You obviously mentioned your self-service is one of your ways of trying to make the system that you built more maintainable and less touch for your team.
Right.
What else are you doing to drive, a more touchless, more automated, less your team has to maintain some product within the walls of your own company?
Right. So I mentioned we have an SRE team now. We're working on those data center migrations, which we have to do a little too often, and working on just automated tooling around, hey, CPU looks high on this particular node. One of the challenges of working in a virtualized environment is sometimes hypervisors get stressed. We have machines in those hypervisors, and so all of a sudden CPU will jump from up to 100% and won't come down. Well, it's easy enough to move that to another hypervisor or rebuild that machine and hope it ends up on a less stressed hypervisor automatically. So we're working on that tooling now. Again, a lot of the time we spend is just wasted on ad hoc user queries. How do I use this system that I know nothing about? So investing up front in a better user education program is something that we consider we need to lean into it, right? We've been a bunch of software developers, or at least myself, someone with a software development background. The rest of the team is mostly software engineers, and we tend to try to run away from all that ugly work. And as a result, we actually have ended up creating more work for ourselves, right? We need to lean into it enthusiastically in strategic ways to reduce the amount of work that we're doing. And both of those are efforts to do that, both the SRE work and the user education work. Those are areas where we could do it in a way that's probably a lot less painful and benefit from the reduction in workload of unplanned workload on the other side. So, did that answer your question?
Yeah, it's a common problem. You become a victim of your own success when
Yes.
your own product and you have to maintain it. Is there a more commodity approach you could take instead of your more custom approach? Considered anything, because it's API gateway for common, right?
Yeah, so
More off the shelf you could do?
so we are looking at what our next gen solution will look like, and we're certainly looking at lots of solutions. Hey, I'm at an NGINX conference. I'm probably going to look at some new features that have been added here. We are big fans of open source, so I don't know that we'll end up going that path. We're looking a lot at service mesh solutions right now. The problem is that when you serve 1,500 services, and some of them are very advanced microservices running in Kubernetes, and some of them are monolithic architecture running on physical hardware sitting in a data center somewhere, it's really hard. Microservices, all of the service mesh solutions that we're looking at are really assuming that you're running in Kubernetes pretty much, right? We have to serve a world where the minority right now is in Kubernetes. We certainly hope more and more of our clients will be moving there over time, but I can promise that some of our clients will never get there, right? So we're kind of stuck there, but we're thinking about that a lot. Yeah.
You have to deal with bringing about this cultural mindset in the DevOps and the culture in your team. What was the experience?
So within my team, it went pretty well. It's certainly something that I think every company that makes that shift struggles with, right? And Comcast is a big enough company. Look, there's 190,000 people. There's a team somewhere that does every way you can imagine doing something. There's a team that does it somewhere. So other teams have struggled more with it than we have. For the most part, I think where my team struggled with it, as I talked about a little bit, wasn't necessarily embracing it and being enthusiastic about it up front. It's really the day-to-day reality of, some of that work is not glamorous. And the not glamorous work tends to be the work that you have to drop everything and work on immediately. It tends to be your biggest priority. So that's not necessarily the most fun thing in the world, but again, shifting away from DevOps towards an SRE approach, which for those, if you're not really familiar with the differences, people have given hour-long talks about what SRE means, but really it's basically the attempt to automate everything that you can. Every terrible operational task that you have to do ought to be done by machines rather than humans. And as we're working on that, I think that it's a little more exciting to work on something knowing, hey, I'll never have to do this again once this is done, right? People tend to be happier about that. Anyone else? All right, well, thank you very much.